Hey, young grasshoppers. I hope everything is going great back at Peak to Peak. First of all, when one of you becomes valedictorian in 4 years, you better thank me for this. A bunch of you emailed me wanting to know if you could get help on conservation of energy and conservation of momentum. So I'm going to make 2 quick videos. I'm just going to walk through a sample problem in hopes that that will help you answer one of the choices of sample problems. So for conservation of energy, I am going to actually use number 1 from the class copy. So if you did number 1 as your sample problem, that's really unfortunate because now you have to pick a different one. Because I don't want you just copying what I'm doing. So here is the problem. A 3-kilogram toy dump truck. So here's my object. The mass is 3 kilograms, and it's moving with a starting speed of 2 meters per second up a ramp. How high does the truck roll before it stops? So the key to this problem, look, I'm pounding like this. The key to this problem is that the kinetic energy, when it's moving at the bottom of the ramp, has to be equal to the potential energy when it's stopped at the top of the ramp. Let me repeat that. The kinetic energy, when it's moving at the bottom of the ramp, has to be equal to the potential energy when it's reached its highest point on the ramp. So if I were to show that, I hope you can see this. So if the box is right here, right now it's 100% kinetic energy. And then when it gets to the top of however high it's going to go, we don't know that, that's what we're solving for, it's 100% potential energy. So if you can figure out the kinetic energy here, it's going to convert to potential energy here. So I know that kinetic energy equals 1/2 mv squared. So I can find the kinetic energy at the bottom of the ramp, and it is 1/2 times my mass, which is 3, times my velocity squared. So my kinetic energy, 2 squared is 4, times 3 is 12, times 1/2 is 6, and the unit is joules. So I know at the bottom of the ramp that it has 100% kinetic energy. It has 6 joules of kinetic energy. And as it goes up the ramp, it's going to lose speed but gain height. Let me say that again. It's going to lose speed, but it's going to gain height. So when it gains height, when it gets to its highest point, it's going to have all potential energy. So I know that at its highest point, it has 6 joules of potential energy. So if I know that potential energy is mass times gravity times height, I can say 6 joules, which I know is the maximum potential energy it can have, and that's at its highest point, is equal to 3 times 9.8 times the height. Okay? So if I want to figure out how much height it has at its maximum point, then I have to take 3 times 9.8, which I didn't do before this video. So 8 times 3 is 24, 27, 29. So 29.4. So 6 joules equals 29.4 times height. And then I want to divide both sides by 29.4. You're going to get some small number because the box is not going to go very far up the ramp. Okay, 6 divided by 29.4, and I'm sorry, I didn't do the math ahead of time. So I don't know, it's about 1/3-ish, so maybe 0.33-ish meters. You can do that math if you want to see how that equals out. So the point to this problem is there's no equation to memorize. The point that you have to know is that when something is only moving, it has no height to it, and then it transfers to a height, assuming no friction, assuming no air resistance, that beginning kinetic energy is going to transfer all to potential. Now once it reaches the top of the ramp, it will roll, is it a ball? It's a toy dump truck. It will roll back down and be all kinetic again, right? So it's all about the transfer of energy, just like the snowboard physics problem. So Ty, Mike Scott, turn around and listen please. Naveed, quit making comments. Thank you. Tim, turn around. Okay, so now that I have your attention, remember that kinetic energy goes straight to potential and then can transfer back again, and all you have to know is if this is true. And if it's true, then you can set up these two equations and you can figure out the unknown.